Welcome back to Basically Science. Can you imagine how difficult it must be to have a food allergy? I mean, I don't personally have one, so I wouldn't really know what it's like. But in this episode, we're going to break down what exactly is an allergy, what is a cause, and how it's treated. We have a degree in integrative sciences, which is specifically designed to provide an interdisciplinary education of both physical and life science. We use this education to help you understand where science meets the world around us. If you stick around to the end of this episode, I will share why EpiPens work. By the end of this episode, you should have an understanding of the fundamentals of the immune system, anaphylaxis, and how EpiPens work. Parker, I want you to imagine this, okay? You are 11 years old, and you're going to go to the beach because your family doesn't typically go to the beach, so this is going to be a new, exciting experience for you. And to celebrate, your family indulges at a crab shack where there's more crabs than you could ever possibly eat. And as always, they're perfectly cooked, buttery, well seasoned, and you're loving it. You're having the time of your life. And then all of a sudden you feel a slight tingling in your throat. Your heart begins racing, and you feel this surge rushing through your body, almost as if it's like an anxiety. You start breathing faster, and you feel like you can't catch a breath. Your tongue swells, making breathing even worse. Your parents quickly realize what's happening, and they call 911. And you end up going to the hospital for several hours, but manage to come out alive. Do you know what happened to you?
Yes, the accumulation of some dire decisions that an 11-year-old has to make is
Is
totally now. It is the interaction between how my body is responding to this food that I just enjoyed very much.
You're right. You had a allergic reaction, and the most severe case called anaphylaxis. So, while you were in the hospital, you were likely treated with a variety of medications, but we're going to get into some of those in a little bit. The system that was acting in that case was the immune system, which is a complex protection mechanism that is part of your body. And the immune system is multifaceted. It's an organization of proteins, cells, tissues, and without it, quite frankly, our bodies would be vulnerable to attack from outside invaders, known commonly as foreign bodies, or in the immunology world, antigens. To first understand allergic reactions or anaphylaxis, we have to start by understanding the basics of the immune system. So let's first talk about the origin tissues of the immune system. And there are many types of cells in the body that are immune system related. These cells can be categorized in several different ways, and one of the large categories is white blood cells. Do you know where you can find white blood cells?
Well, it have to be in the blood.
Right, because there's no way in the world that question would ever stump you, right?
Yes, absolutely not.
just for reference, everyone, I had asked this question to Parker in a draft recording prior to this, and well, to be quite frank, he had no idea.
Yeah, I went X Games mode on the
Yes,
question.
you did.
Yeah.
Well, it has to be, because of this, yeah. But white blood cells are also go by another name. They go by another name called leukocytes. Can you think of anything that reminds you of the word leukocytes, or does it ring a bell?
Yes, most notably in leukemia.
Absolutely. So leukemia is a cancer of the white blood cells. But white blood cells, they can be stored in the thymus, which is a gland in between your heart and lungs. It can be stored. They can be stored in the spleen. They're made in the bone marrow, and they also exist in the lymph nodes as well as floating around in your blood. Leukocytes can be further classified into phagocytes and lymphocytes. So we're going to start to kind of get into the different cell types here, and I want you to try and stick with me because although it seems complex, it's really important if you want to understand anything about the immune system. Uh, Phagocytes, which is like that further classification of leukocytes, phagocytes absorb and break down other cells. They're eater cells. They eat other cells and break them down. And there's a couple different types. One is going to be a neutrophil, and they commonly tend to attack bacteria. Another one is a monocyte. They're the largest, and they do a bunch of different things. The third, which is probably one of the most popular, are macrophages. Macrophages patrol for pathogens, and they also remove dead or dying cells. And that could be like your own cells that are dead and dying. And then there's mast cells, which help with healing as well as pathogen defense. Okay, so those are 4 types of phagocytes. Remember, phagocytes are the ones that are going to absorb and break down cells. Lymphocytes, on the other hand, help recognize and remember foreign bodies. There are 2 types. B lymphocytes, which produce antibodies and they alert T cells, and T lymphocytes, or T cells, and they destroy compromised cells and recruit other leukocytes. There's 2 major types of T cells: helper T cells, which coordinate the immune response by recruiting cells and stimulating antibody production. And then there's killer T cells, which kill compromised cells. Okay, so that's kind of like the basics of, the basic components, some of the basic components of the immune system. Do you have any questions about that?
No, it's just like I guess sort of like those are the key players in
Right.
the process when you're talking about something happening to the body, something abnormal, like
Right.
anaphylaxis. Yeah.
And those are going to be the, I guess, the players that are active. Does that make sense? They are alive. They are doing things. They are metabolizing just like any other living cell. The other players, such as antibodies and antigens, they typically are not alive. I mean, bacteria are alive, so that's different. Viruses, it's questionable, but they're typically considered to be not alive. Other things such as like proteins, that's what I'm considering non-active players in the immune system because they're just as important. And we're going to kind of get into a little bit of those right now. So when an antigen enters the body, this is what occurs, okay? This is the immune response. So let's assume this is a new, never before seen antigen. The antigen is going to first be recognized by a B lymphocyte, which will then learn the antigen and produce a marker protein that is specific to that antigen, and that is called an antibody. Antibodies are a part of a family of chemicals called immunoglobulins. They are titled Ig and then a letter such as A, B, C, E, whatever, afterwards. So an example would be IgE. Different immunoglobulins do different things. These B lymphocytes then release the new antibody to bind to the antigen, creating what we call an immunocomplex. Okay, so that's an antibody and an antigen. Because the antibody is now bound, it can be recognized by a T cell. The helper T cells typically recognize it, and they help recruit the appropriate leukocytes and the killer T cells as needed to to essentially deal with the antigen.